Hi everyone, and welcome to Shaping Spaces Environmental Design Series. This is a series that delves into the complexities and opportunities in environmental design for buildings. In each episode, we're going to bring together a panel of technical experts in various specialisms such as acoustics, air quality, pedestrian wind, exhaust re-entrainment, geotechnical, and so much more. We're going to explore how these disciplines intersect, clash, and ultimately, ideally, work together to shape projects in this space. This isn't just a technical deep dive, just so you don't get worried and scared about that. It's hopefully a relaxed, insightful conversation aimed at architects, developers, and other professionals in the building design industry. Each episode is going to introduce you to our team of experts here at SLR Consulting, highlighting real-world projects, and we'll provide some actionable tips and lessons learned so you can not make the same mistakes that we've observed. We'll also feature guest speakers, ideally, including architects, building developers. So if you're one of those, please get in touch, hoping to share their perspectives and experiences working in this kind of space. If you'd like to be part of a future video, please email me at dclayton@slrconsulting.com. And if you'd like specific topics or questions answering in the future, please comment below and we'll include them in a future video. So in this series, we want to show how we balance required design spaces that meet environmental, functional, and aesthetic goals, all while keeping the kind of human factor and experience at the heart of our conversation here. Today, we have three experts to talk about the design of a healthcare project. Healthcare buildings are some of the most complex environments to design. They need to support patient healing, staff efficiency, and strict regulations, all while balancing environmental factors. Just before we dive in, we're all from SLR Consulting in the Canadian business. A quick intro to us. We're a global team of experts helping clients tackle environmental and sustainability challenges with 4,000 people now. That's changed a lot from when I started 6 years ago, from 1,300. We work on projects of all sizes, from strategy to planning to hands-on technical solutions. So in Canada, we collaborate locally and also on international projects, bringing global expertise to solve those problems in a practical and real way. So today we'll explore a real-world project example and discuss how these factors shape design decisions. Our experts today are in acoustics, air quality, and pedestrian wind, where they'll share their experience to help you inform your next project, as well as how to balance those competing design objectives. So myself, I'm chairing the discussion today. I'm Dan Clayton. I'm based in Calgary in Canada. I'm originally from the UK, as you may be able to tell from my interesting accent. If you have any issues understanding what I say, Google is your best friend for any of those phrases that come out. I'm the acoustics and vibration manager in the Canadian business for SLR. Been here for 6 years and I've worked in the industry for over 15. So I've got a bit of experience working on these projects as well, but it's not about me today. It's about others. So my role here is to facilitate interesting conversations with our experts. So we'll do a quick whip around the table to get people to introduce themselves. So first of all, I'd like to introduce Banda Logawa, who is our expert in acoustics.
Thanks, Dan. My name is Banda. I'm Senior Acoustics Engineer at SLR. I'm based in Vancouver, BC. But I've done work in BC and the East Coast as well, in Ontario, and also some of the projects in the States as well. Healthcare projects is dear to me, actually. Thank you for choosing this topic, actually, Dan. Recently, well, of course, after COVID-19 and others, we have seen a lot of new hospital projects, whether it's a new building or it's the redevelopment project. And each of those, they come with their own challenges as well. And it's always a fun time for us to work on those type of projects, because it's one of the projects that is pretty involved and collaborative as well, mainly because we get a chance to work with other team members, even the same company. We can look at different aspects together, and that's about it for me.
Thanks, Banda. Thanks for that. And Jason Slusarczyk is our air quality expert. Jason, just say hey.
Hello, Jason Slusarczyk, Principal Air Quality Consultant, located in Guelph, Ontario, but similar to Banda. I work on projects all across Canada and all across the U.S. In fact, most of my project experience probably is with regard to U.S. projects. We generally help architects and engineers solve air quality situations with their projects. And I would like to thank you, Dan, for picking healthcare, because it's the most challenging area that we work in. There always seems to be a lot of limitations and constraints on those projects. So they are especially challenging sometimes.
And last but not least, Tahrana Lovlin, who is our pedestrian wind expert.
So hi, I'm Tahrana. I'm a principal in Microclimate at SLR. I've been doing this for more than 20 years. playing with pedestrian wind and snow. So really how buildings interact with those who use them. Healthcare, again, provides a challenge because of the users of the building and how the outdoor spaces interact and just the fragility of the population that's using the building. So pedestrian wind becomes a value-added aspect of it. And in some cases, depending on the climate, snow drifting as well becomes something to consider in the overall operations and maintenance. So we get involved again with architects, and I've worked over the course of my career around the world on various healthcare facilities.
Let's get into the key technical factors in healthcare facility design. So today we're looking at acoustics, air quality, and pedestrian wind. There's lots of other areas that can influence the design, but we're just focusing on this kind of three together that tend to work together most commonly, I'd say. They are very common in terms of like directly impacting patient recovery, staff performance, and overall building function for these healthcare facilities. Today, we're hoping that the experts can give insights on the challenges and solutions and what architects especially should keep in mind early in the design process to avoid issues down the line. Tahrana, I just wanted to flip back for you. We aren't doing a specific study. We decided not to do a project example specifically just in case there were any issues, but I think generally we just wanted to have a general design project to talk about. Do you have one that you could share that we could kind of open the discussion up with?
The one I can think of off the top of my head is in addition to an existing hospital facility in the northwest of the U.S. So what they did was they had an existing facility that was about 5 or 6 stories tall, branching over a block, and the intention was to double the square footage. And what they did is they put in a patient tower with 14 stories, a helipad, various outdoor amenities and terraces. They had to bridge it over a city street in order to expand into a second block. So there's a lot of moving pieces that I can think of.
That's a great one. So let's keep that in mind. But I think we should initially just, before we discuss those things, that's coming later for you viewers who are eager to hear more from our experts, we'll talk a little bit about setting that up in terms of what's important to each of the disciplines that we've got experts for today. So I think we'll start with acoustics on how sound control supports that kind of healing and communication. And then we'll move into air quality, how ventilation systems and managing contaminants and why placement and airflow might matter. And then finally, we'll cover pedestrian wind on how wind patterns affect entrances, spaces, outdoors, and user comfort. So once we've gone through the disciplines, we'll discuss how they work together and sometimes push against each other in terms of this project setup that we've described. And then we'll get some key takeaways as well at the end for designers to look at these elements so they get things more right at the start of the project rather than at the end or after the thing's built, which we've seen. So acoustics. So hospitals are noisy. There's equipment beeping, staff moving around, and HVAC systems running round the clock, really. And at the same time, a quiet environment is critical for patient recovery and clear communication. So I want to talk about how we manage that balance. So Banda, question for you. What are the key acoustic challenges in a hospital and how do you design around them?
Well, you've got a really good point, right? Because in hospital building, you want patients to be able to recover well. You want them to be able to relax in the space. But then, of course, a lot of the supporting equipment, a lot of the busy activity in the hospital may prove to be challenging in that sense. So, and especially something that's very interesting, because Tahrana mentioned earlier about a project that involved an expansion, right, to an existing hospital. That's very tricky, actually, because from my experience, having to build something, construct a new hospital building nearby an existing one is always challenging, mainly because you want to make sure that everything is up and running in the old hospital building, but then you also want to make sure that construction goes smoothly. A lot of different challenges with vibration, ground vibration, a lot of different challenges with mitigating noise transfer from the construction activity itself. Sometimes we get involved really late in the project, sometimes during construction document stage, or even there's one time that I was involved during tendering process, right? They want to purchase an HU unit, they want to purchase an exhaust fan unit, and they are concerned about acoustics because apparently it's going to be affecting the patient rooms, right? So, but nowadays, what I've seen is it's getting a lot better. In Canada and the US as well, we are starting to be involved early on, and I really enjoy that collaborative process as well with the architect and the other mechanical engineer and the other engineers as well. So that way we can figure out, okay, so if this is a patient room, then it shouldn't be nearby, or it shouldn't be above a generator room, for example, right? Because as you know, in hospital building, it's very important to have equipment up and running 24/7, and it's very crucial for them to test all of the emergency equipment as well. And if there's a very sensitive space above the mechanical room or a nearby mechanical room or generator room, it's going to be pretty difficult for a patient to sleep or to relax and enjoy, right? And then of course that's the indoor part of things. But then of course in hospital buildings nowadays we are seeing a lot more outdoor spaces as well, so that it can help with people with the recovery process. And looking off the outdoor noise sources, we have the ventilation equipment. Even sometimes we have the helipad as well, right? We do want to make sure that the location of the outdoor spaces are well thought out, making sure that like the space, the programming of the space are well thought out, right? Making sure that we identify where are the noisy equipment going to be, where are the vibration generating equipment going to be. And the same thing with the receiver as well. The patient rooms, the surgical rooms, and also any imaging equipment, for example. Because vibration, ground-borne vibration from equipment and even from people just walking around as well, if it's not properly designed, it may affect the imaging equipment, right? So we do want that to be considered early on. And in some cases, like if you have other noisy, not necessarily equipment, but for example, if you have a pneumatic tube system, right? You want to make sure that it's not going to pass through any patient room, or if it's going to pass through any patient room, then you want to make sure that you mitigate that as well. And making sure that we understand where the noisy equipment are going to be, or vibration generating equipment are going to be, and also the receiver side as well.
Noise is a key part. I'm a little bit biased from my experience, but one thing that interests me and especially comes to mind when you think about it most is kind of the air quality requirements in a hospital. You know, there's ventilation systems moving air around, there's particles moving in the air that you don't necessarily want to exchange between people. So there's obviously big challenges there, both inside and outside the building. So Jason, I want to lean on you here. What are the kind of biggest air quality priorities in hospitals for you, and how do they kind of influence the design of a project?
Sure, thanks, Dan. And I'll build upon what Banda mentioned a little bit, but just as an example with a healthcare project, I think just fundamentally, in my experience, new designs and master plans are difficult enough for the architects and engineers to make all the different pieces work and avoid cross-contamination. But more times than not, building projects are incremental. So they get new funding, it's wing by wing, it's new hospitality services, there's a new patient tower, there's a new addition of a helipad, there's addition of new backup standby diesel generators. And so it's very difficult. And there's a smattering of air handling units located on different wings and different rooftops. So again, new design is difficult enough, but the hospital projects are difficult, and the new additions are very difficult just because there's so many points of cross-contamination. I think in a broader sense, Dan, obviously indoor air quality is a major concern, but often the indoor air quality can be compromised from exterior exhaust sources. So as an example, one of the major challenges that we encounter is just keeping exhaust odors from unwanted odors getting back into the building, whether it's from large kitchen exhausts, whether it's from diesel ambulances at their bays or loading docks, or most commonly standby diesel generators. And there's a huge requirement now for more power and standby backup power, and larger generators are going into these facilities, and more generators are going into these facilities. And there's usually a requirement for weekly testing and under some sort of load. A lot of privately owned buildings might only test a backup generator once a month. It might just be in idle condition. But at these hospitals, there's load banks. They're putting out a lot of exhaust, and the wind or the atmosphere tries to disperse, all of this odorous exhaust, and it's difficult. So what happens often is that these exhaust fumes and emissions can find their ways back into the fresh air intakes and basically contaminate or impact or cause nuisance odors throughout different parts of the buildings. We've had stories where, in surgery suites, and they're smelling hot dog vending outside on the sidewalk, or they know when the groundskeepers are mowing the lawn because they can smell it. And honestly, sometimes there are requirements to shut this down. This isn't safe. So we work a lot with the mechanical engineering team and the architectural design teams to try to help mitigate some of this cross-contamination.
Is there any initial kind of tips you can give architects on designing these spaces from like a principal feasibility layout standpoint for these problems?
I think there's two sides to it. There are all of the exhaust points and all of the exhaust fans and all of the exhaust stacks. So there are numerous points of emissions, cooling towers, kitchen exhaust, dedicated laboratory fume hood exhaust, diesel trucks, ambulance bays. So numerous exhaust sources to pay attention to. And then the other side is there's lots of different air handling units and fresh air intakes. So it is a mishmash, and it's very difficult to have one single solution that solves all that problem. So I think just an appreciation, a recognition that there's two sides. It's very difficult to just, mitigate all exhaust sources. It's very difficult to just mitigate all air handling units. There's going to be all different levels and complexities of cross-contamination. So one, I think just a higher appreciation of issues do occur. We get called in not just on new designs, but brought in after the fact that issues are now occurring, and they're looking for solution options, and they can be difficult to solve. On new designs, there's a little bit more opportunity to get things right. And I would say the biggest piece of advice I could do there is start with your fresh air intakes, because they take up so much real estate and they're very difficult to move and mitigate afterwards. So typically get the intakes in the proper spot, seek early advice, pay attention to the existing surrounding environment. It might be a neighbor's exhaust sources that are being re-entrained into your own fresh air intake, maybe not your new exhaust sources. So start on the fresh air intake side, get those right, then work on fan locations and try to get to the higher rooftops and good stack designs.
So we've done noisy stuff. We've done smelly stuff. Now, this is something that I didn't particularly relate to, building design at all, really, until the past few years. And it's how the kind of air and wind moves around a building and how this is actually factored into building design. So, looking at outside spaces, making sure they're safe and comfortable, it can create challenges, but how do we manage this aspect of things in hospital design? So I'm going to lean on Tahrana now. So how does pedestrian wind impact hospital design, and what are some of these kind of common issues that you have to factor in when you're giving your advice?
So hospitals, when you're looking at the population, so you want the wind conditions around entrances and exits to be as calm as possible, because just the fragility of the people using the space. And when you start going taller or building in either exposed environments or urban environments, things can get windy. The higher you go, the stronger the wind flows. And if you put a tall building up or something that peaks up above its neighbors, it directs the winds down. So what you try to do then with entrances and exits, particularly main entrances, is how do you place them on a building so that they're not bearing the brunt of the prevailing winds? And so one of the things we like to look at early is the wind environment. Where are the prevailing winds coming from? And then how do we provide shelter to those entrances? To the same with outdoor amenity spaces. Again, you want them to be as calm as possible for the fragility of the users. And so how can you place them? They tend to be placed either, in sheltered courtyards, which is a great idea. If you're placing them, if it's a new tower, where do you place it around the tower? Do you place it on the podium and such? Do you place it downwind and that kind of thing? So we very early in the design can provide just some general guidance of where would you put main doors and stuff, and how does that connect to existing sidewalks and such.
You kind of summed up everything I was going to ask around your specific topic. So I think let's move on to some of the kind of like where these disciplines interact, because this is where the real interesting piece, and we might get some arguments going, which is exciting. So like what we want to do is really talk about, a bit of around the table here, but Tahrana, I guess, you must have had clashes with your, not necessarily your colleagues currently here in the room, but like others that work in, acoustics or the air quality space, where you want something a certain way and the others want it another way for different reasons. And I just wanted you to share an example of where that clash had occurred in the past.
Strangely, Dan, I very seldom clash with other disciplines. Where I clash is usually with myself,
okay.
Which makes it even more entertaining. So pedestrian wind, you want winds to be calm. But if you're in a region like Canada or the northern US, you're also dealing with snow. And so you don't want snow to accumulate in front of a door, but you don't want it to be windy. And so we sometimes play these I play these lovely balancing acts as to what is more important. How exposed is the door? How much snow could get in front of a door? Do we want to do sustainability and get the wind to clear it, but then the wind will play into potentially door operability and can you open the doors? So that's usually where I clash. Is really, it's an internal battle with myself most of the time. Strange.
Which one tends to win?
Tends to win because pedestrian wind comfort and wind is like 12 months of the year, 365 days. Wind will win 90% of the time, but in a few places with really heavy snow, Quebec, New York State, that kind of thing, snow can sometimes win, just because of the volume of snow they're dealing with and the effort it is to remove it.
Interesting. So do you ever, just a side comment, do you ever deal with situations where you're looking at like wind loading on a particular part of a building that might cause damage to the building, or is that more something else that someone else look at?
That's something else. So yeah, pedestrian wind's really just dealing with the people who access the building. When you get up into cladding loads and structural loads that are code-based, that's a completely different area, and that's sometimes maybe where Jason might clash with things, but no, it's not something I deal with.
Okay, great. It's good to clarify. At least I learned something. Jason, you must have examples of this, I'm sure.
There's probably lots. I think the first thing that comes to mind is normally to have exhaust emissions disperse into the wind. We like to have, stacks on high rooftops and very up in the air where the emissions can get into the wind. That causes aesthetic concerns from often, and which we're trying to balance. Structural concerns. And from a noise concern, we are always trying to get exhausts, above nearby sound barriers and screening walls, and higher exit velocities and more horsepower, to shoot the emissions high into the wind environment. Where from a noise point of view, we're often trying to shield a lot of these the high exit velocity noise from air, noise from larger fans. So we do overlap on the environmental noise side quite a bit.
How does that make you feel, Banda?
It's always fun to argue with Jason on this. Just building up on what Jason has mentioned earlier, the exhaust sources. Of course, from noise point of view, we do want it. We do want the noise barrier to be able to block the line of sight, so that we get some kind of reduction. But then, of course, Jason wants to put it very high above as well. If I just put my acoustic hat on without thinking about other aspects, then I'll just say, okay, all noise sources, even the exhaust and intake, they should face away from any sensitive receiver, right? Even though they are at the same face, for example, the building, ideally they should be there. But of course, from exhaust and re-entrainment point of view, you do want to have a good separation between the two. You don't want the exhaust air to recirculate and come back in through the intake as well.
And Jason, I'm a solutions person, as you already know. What do you think the answer is, though? Like, the building has to get built. And so in your experience, how do these two work together? What does someone win? Is there a compromise that kind of meets everything? Like, I'm intrigued.
I'll get to the real positive answer in a second. The unfortunate thing is, it's many times it's the lesser of two evils, right? So you're just, sometimes it's just what is the best solution. It might not be perfect. It might not be 100%, but for most wind conditions or 90% of the time, we're going to have the best design. And there's educating our clients. There's helping our clients educate, the owners or their clients. On the more optimistic side, on new designs, I mentioned getting that fresh air intake or those intake locations established early, and with good design, a lot of the headaches and problems can go away with by getting those sensitive receptors in the right spot. A lot of times we don't have to get into taller stacks or struggling with visible stacks. If we've got the intakes in the right locations, it often solves a lot of the mitigation. Most of the difficulties come when we've got multiple intakes on multiple rooftops at locations, and we're trying to balance different wind directions and different exhaust sources, and it can get quite complicated. So I think one solution is clean up the rooftop with respect to, I'll say the rooftop, assuming that's where the exhaust fan or the exhaust stack is, the local area with regard to sensitive receptors. In general, if we can get fresh air drawn in a little bit lower on the building or off the rooftop, and the exhaust stacks up onto the higher rooftop, although the wind can knock exhaust emissions down and downwash to those built intakes, it is more difficult and we get much better dispersion. So a general design strategy for success is to get it's a little bit common sense, but it's not always an option, but to get those exhaust fans and stacks a little bit on the higher rooftops and to pull fresh air in from a little bit lower off.
Jason, do you worry about prevailing winds then? Like, do you look at that kind of thing, or is that usually too complicated?
Great question. So we always look at the winds. We try to design so that we don't have issues under all wind conditions, especially if there's sort of hazardous emissions involved. So we try to say we're good to go all the time. Many times, especially with odorous exhausters, large diesel generators are a perfect example. You almost can't guarantee that you won't get some level of odor re-entrainment if you've got a large 2,500 kilowatt generator running at full load. If the wind's blowing a certain direction, those odors travel a long distance, and especially in an urban environment, they can get the dispersion can be limited by building walls and things like that.
Is there a rule of thumb, like on simple buildings? Is it put the intakes upwind of the exhaust? Is that like the goal if we were to simplify it or not? Probably
half the situations I see, probably the mechanical design team has considered that. Obviously, they're looking at winds too. They're trying to get things aligned properly to help reduce potential impacts. And I would say half the time, it's a good strategy. They've put the exhaust on the downwind side with the fresh air intake exposed to the predominant winds. However, there are many situations where the wind is going the exact reverse direction. So on the back side of a building, you try to locate your generator on the downwind side of prevailing winds, but you will find that those exhaust fumes actually come right back towards the building and hug that downwind wall, and you can get severe re-entrainment. So sometimes the local winds are going the opposite way of the predominant winds. The other thing I just like to say about prevailing winds, predominant winds, whatever terminology you like, it's very rare that we see predominant wind directions greater than maybe 20, 25, 30% of the time from a few directions of the compass. So even in those situations, 75% of the time, the winds are coming from different directions. So we really do, we consider the winds, but usually we take most advantage of them to reduce odor impacts, not necessarily hazardous type emissions.
Interesting. Wow, everyone's getting fired up. I like it. So, Banda, one question for you. I know you reflected on fences and acoustic barriers and things like that. Like, if that's not feasible, that can be a potential contradiction. Are there other solutions that could apply that could get you a similar result? Like, when would you have to use a barrier and when would you not?
The best time that I really enjoyed as well is early on in design, where we can locate all of the exhaust sources. We can comment on it from the noise point of view as well, not just exhaust re-entrainment. And then we can identify, okay, so we have to meet a certain noise level, for example, if there's any noise ordinance or noise bylaw that will apply. And then we flag, okay, if you put it this way, then the mitigation will be quite onerous, right? It can mean that you have to have very good muffler, or you need to have a deep acoustic louver as well. In most cases that I've worked with, we managed to find a solution that works for acoustics as well. For example, if it's not a noise barrier, it can be equipment reselection. It can be like acoustic louver, acoustic silencer, or even for example, if your receiver is indoor, then we can take a look at the facade construction as well, and then comment on the window construction or the wall construction, what can be done to increase attenuation towards the interior spaces.
This has been great. I've learned a lot, even I know you all, and it's been interesting to learn a few different things and different angles and how you all talk together in a project meeting. Every project has taught us something, but before we wrap up, let's highlight a few key lessons architects should take away from this discussion. So I just want one thing from each of you. What's one piece of advice you could give to architects, Banda?
The most important one is aligning expectations. For example, as we talked about earlier as well, new building and expansion to an existing building has their own different challenges as well, right? And by aligning expectations with the client, with the designer, with the engineers, then we can all come up with a good design. And having the opportunity to, for example, do some kind of measurement in the existing building where people are using the space, where they are satisfied with the condition, and we can use that as a baseline. That's usually will be helpful for those challenging expansion projects. So.
Tahrana, for you, what's the one takeaway for architects?
Can I give two?
Yeah.
Okay. My first one is don't discount pedestrian wind. It's not something normally talked about, but it really plays into how people view your building. If they can't open the front door, if they can't walk to the front door, that first experience can taint the whole experience. So don't discount it. Like, think about it earlier in the design. And the second piece, and it's really simple, don't put doors on corners. Oh, for God's sakes. It's the windiest place on a building. Don't put doors on corners.
Good advice to live by. Maybe you could do some merch if the show really takes off. Get some t-shirts.
Absolutely.
And last but not least, Jason, any thoughts on takeaways for air quality?
If I was to speak right to the architects, just an appreciation that there's always limitations in your design. So although it might not think initially that expertise is needed, your mechanical engineers are going to encounter difficulties, right? So locating all of the exhaust sources and the fresh air intakes to avoid cross-contamination can be difficult. I guess the overarching design strategy, I'll just try to get those exhaust sources and those emissions up higher into the wind and try to pull fresh air from a little bit lower. It works a lot better than the other way around. Once we get sensitive receptors or fresh air intakes on a higher rooftop with exhaust down lower, it's very difficult to mitigate those situations.
So that's it for this episode of the Shaping Spaces Environmental Design Series. We've covered some great insights to make sure that people aren't getting annoyed by sounds, or they aren't breathing in the wrong things, or they're not being blown around outside. It all plays a part in designing these critical infrastructure healthcare buildings, and how those disciplines, it's just a sample of some of them involved in a project, how they're just competing just from this conversation. So hopefully this gives you a better understanding of how to approach these challenges in your own projects. If you found this discussion helpful, let us know in the comments. That would be amazing. And if there's a specific topic or project type you'd like us to cover in a future episode, we'd love to hear your suggestions there as well. If you want to be part of one of these conversations, please reach out to me. My email will be in the description. And we're always looking to bring new perspectives into that mix. So thanks for watching, and thanks to all of the experts on the call today. It's been great to get your opinion. So thanks, Tahrana.
Thank you.
Banda.
Thank you.
And thanks, Jason.
Thank you.
Thanks, everyone, for watching, and you'll see us in the next one.